We're going to have to move on to our next speaker now, who is Victoria. And Victoria, I can see you, so that's a good sign. If Mahesh, you can stop share. There we go. So can hear you as well. That's fantastic. And Victoria, do you have some slides to share with us? You're going to be telling us today about the link between science and journalism and how presumably we can make journalists tell the proper story more often.
I hope so. I do have slides.
Okay, we can see the slides. If you can just, yep, you're in presenter mode. We can hear you and we can see you. So yeah, you're good to go.
Okay, just a moment. So hi everyone, thank you for letting me join you today. I really appreciate it, especially since I'm a journalist and it's nice to cross over to the side I like much more from time to time. I'm going to talk about education in the media sphere, obviously, and I'll start a bit from afar and get to the case. So in the consciousness of Russian people, our country is a space power, or more, it has a special a status of a space pioneer country. And interest in space exploration is consistently high. And considering the establishment of a new space race in which more than 2 countries are participating this time, Russians' attention to space has become more intense. Thus, we see that demand for space journalism is higher than usual. However, for many people, space journalism is all about space flight and mainly manned. Astronomy is noticed less, at least in Russia. Its practical benefits are not understood by everyone, just as not everyone is able to appreciate the importance of fundamental scientific research. Just as not everyone is able to which has no obvious practical application. I believe it's up to journalists to fix that uneven representation of space-related science and help the audience to learn a new perspective on a humbling and character-building experience of astronomy. But to do that, journalists still need to learn a lot themselves, especially in Russia, in Russian context. At the turn of the 20th, 21st centuries, Russian science journalism was dominated by authors who were scientists by education. As a result, there was virtually no room left for trained journalists aspiring to report about science. Today, specialists with a journalism degree cover science, but the change has led to a drop in standards, since many journalists do not have the knowledge and skills necessary to provide high-quality coverage of scientific matters. Of course, there are other reasons for that, but my presentation is less about inner changes in journalism and more about its connection with science. So I would like to share an overview of an educational program for a course Space Journalism, originally prepared for students of the Department of Journalism of Lomonosov, Moscow State University. It was a PhD, a final project for my PhD studies. And it was partially tested in form of lectures and at the department and at the science festival Nauka 0+ in Moscow. So I myself studied at the mentioned department for 9 years, received my bachelor's and master's degrees, completed my postgraduate studies while looking for my own path in the field of science communication. And I feel that this puts me in a very comfortable position as a person who knows the problems of space journalism from the inside, and a person who represents the interests of journalism students, and also a teacher who already has experience, albeit small, in teaching astro communication. So in this speech, I will try to tell you about the strategy I have developed for teaching astronomy to journalists. And of course, since I do not have a degree in astronomy, I cannot teach this discipline directly. However, there is a loophole here. I can offer my students an analysis of specific cases of coverage of astronomy by journalists, and not only by journalists, but also by scientists, and hope to spark their interest so they could continue self-education and maybe decide to take astronomy classes online or at the university. Before I get to my suggestions, I would also like to point out that my journalism department of MSU has held courses in general astronomy for journalists and in space journalism in the past. The first course was taught by the astronomer and popularizer of astronomy, Vladimir Surdin, who quite often interacts with the department. But the practice of adding this course to the curriculum had ended before I entered university, and that was in 2011, so very long ago. Vladimir Surdin regularly gives lectures at the department, but as far as I know, there are no plans to return to the former practice of a full-fledged astronomy course. As for space journalism course I mentioned, its author and teacher is cosmonaut Yuri Baturin, who is an employee of the department. As far as I know, he does organize classes nowadays from time to time. The program I have proposed does not take into account the courses I mentioned and could add an extra dimension to them rather than echo them. And I should say that these courses have already inspired a few people to build careers in science communication, focusing on astronomy and spaceflight, which is a good sign. Now about the program I designed, it's for the students interested in science, journalism, and space research mediatization. The practical component of the classes will allow students to apply the theoretical knowledge gained and practice it right away in classroom and also discuss it, which helps a lot. The topics that are covered in this course are proposed up on the screen, and I will expand on each of them a little. So the first one is history of space journalism, and it's all about acquaintance with the historical context of the formation of topic of space research in the media. This particular section obviously starts with astrojournalism, which wasn't called astro right in the beginning, and later gets to the space flight. It also aims to form an understanding of the current state of this specialization of science journalism, and it's very important to let students know about the most notable figures in space exploration coverage and popularization, from Benjamin Day and Edgar Allan Poe. I understand these guys were a bit notorious when it came to science communication, but it's still interesting to study them. To Carl Sagan, obviously, then Neil deGrasse Tyson, Pamela Gay, Paul Sutter, David Greenspoon, and many, many other people that I would like to mention, but don't have any time for that. So the students would analyze features of their activities and their contributions they made to the development of science communication and popularization. I believe this approach gives astronomy face and makes students' relations with it more personal and informal. And it is also a lot of fun to time travel through old media, since this part of the course means that we would work with the archives a lot. Then we have another section, major space exploration events that have captured media attention. Here we focus on discoveries in the field of space research, which aroused particular interest of the audience and led to an increase in the number of materials on space topics. The plan is to analyze the coverage of missions such as Rosetta, New Horizons, Cassini, and others. And PR strategies also of space missions are an absolute treasure, absolutely worth studying. This part includes the analysis of cases. As I have already mentioned, I did a little teaching in astronomy communication, and this part in particular has been tested in class. It did spark a lot of interest, with Rosetta mission being an absolute favorite, given its beautiful PR campaign. Materials published in the Communicating Astronomy with the Public journal were perfect for this section of the program. And addressing the journal is definitely something I would advise to anyone who wants to teach science communication or work in this field and build up the skills. Then we have specialized media dedicated to space research. In this part, we talk about the media containing examples of high quality coverage of science, and also look at the corporate publications of various space institutes. For instance, Roscosmos TV Radio, Russian Space, NASA TV, Sky and Telescope, Communicating Astronomy with the Public again, Startup Radio, Astronomy Cast, Bed Astronomy, and many, many others. It's hard to imagine how we could cover such an amount of resources in one course, but it really depends on the length of the problem, and it can be expanded or shortened. This part is all about learning from the best in business, looking at their style, analyzing the use of like metaphors and stuff like that, which can be very helpful in future work. And now we get to working with sources information, from scientific journals to social media. For me personally, it's an eternal question whether a journalist without a degree in astronomy or a related field can ever be 100% confident about the results of their work. But in the end, we are as good as our sources. We need to get information from credible people, respected scientific journals, fact check and double check everything we come up with. That is a lot of work, and that is in fact a skill which I believe is the most important in our job. So for the journalism students, I propose a list of the main scientific publications in which research results are published, like Nature Astronomy. Again, this part of the course includes information on common mistakes when working with sources of scientific information. There's also an algorithm for searching for news stories and work with English language sources. And the algorithm includes work like from press release to an article to social media, and it all can be really used for efficient coverage, and at least I use it in my everyday work. So there, it's hard to read a text loaded with scientific terms in your own language, but doing it in English when you're not an English native speaker slows the process down a lot. When I started working just working with an article on Mars geology, on one article, and understanding what InSight does on Mars, the basics of it, took me a week of work that extended far beyond working hours. So I feel that the earlier you start exercising, the faster you'll get to efficiency, and it won't just take you a week to read one article. This part of the course also brushes up major newsmakers in space research, Russian and foreign experience, again, such as Roscosmos, Space Research Institute of Russian Academy of Sciences, and others, and also foreign ones, NASA, ESA, European Southern Observatory, JAXA, American Astronomical Society, etc. Knowing your sources, I believe, is the most important thing, and it really helps not to fail with the coverage. And we finish up the course with fake news and common mistakes in space exploration coverage. Here we have specific examples of incorrect coverage of space research. We study the distinctive features of fake news, fundamentals of fact-checking and in space journalism, and we analyze a lot of cases. This part would definitely include some controversial ones. My absolute favorite one is the media coverage of Oumuamua. This case contains everything you need to analyze the questionable news in the field of space research. I'm sure that Oumuamua will teach students critical thinking like nothing else. There are enough theories of the origin of this object, but the journalists chose the most scandalous and implausible and did not give the same attention to other points of view. This case will definitely help future journalists figure out how not to write about science. And I also put up on the screen some of the example of cases, and I would also like to add that in the case of Oumuamua, it's interesting that we have at the heart of the story a scientist with a great professional status, thanks to which journalists quickly built trust with him and his theory. And the very good thing is that he says very clickable things. Oumuamua case can be very helpful to teach students to both report responsibly and remember professional ethics, and the need to check with the astronomical community when the news is just too good to be true. And here I think it's important to be able to connect with scientists through social media. And Twitter is, I think, one of the best places where you could sort of assess some of the news and see what many astronomers think about it. So, as for effects of the already tested parts of the course, it seems that astronomy is the kind of science you can't help but fall in love with. And when you show students the best examples of astronomy communication, it does get a great response. One of the students who attended my lecture shared with me that they wanted to try working as a space journalist. A result I attribute to quoting Carl Sagan often enough through the lecture. In general, students tend to get interested in the topic and actively ask questions, but still more seminars and lectures are needed to see the real results of this course. And also, being an ex-journalism student myself, I have noticed that for many of my peers, it's really hard to distinguish astrology from astronomy. And I have heard many times that people would come up to me and ask me whether they love astronomy, and they say yeah, we love it too, and ask about star signs. So I guess somewhere in this course, it would be nice to incorporate something about the difference between astronomy and astrology. And that's something that is really frustrating for me as a journalist, to see how my colleagues write astrological forecasts and don't really understand what they're doing. So I'm usually someone who's talking really, really fast. I'm sorry for that. So I'm finished with my presentation. Thank you for your attention. And if you have any questions, or if you would like to voice some criticism, or have some advice, I would really appreciate it, because I will be working on this more and hopefully get a better result in the nearest future. Thank you.
Victoria, thanks for sharing all that with us today, and thank you for your time. The one thing that came to my mind when you were speaking is we see it on TV a lot, particularly the last 18 months. Scientists say, or science tells us, and we know that if we put 10 scientists in a room, we have 10 different opinions. Not all scientists sit together and agree on everything. So it's a strange thing to be thinking about science as being this one direction. There's one comment so far, which is from Amit, says that it's a very, let me just try and see, a very sweet and simple thing that every astro enthusiast has to take care. And I think Amit agrees with you about the different scenarios and the different errors and this idea of fake news, which we see a lot of as well. Trust me, it's not something that's exclusive to Russia by any means. Do we have any other comments or questions at all for Victoria? We have a thank you from Mizanur, who's in Bangladesh. I should say as well, I've not commented on it. I don't think in GHOU we've heard from Russia before. I haven't. I haven't personally, right? We did earlier today, but in previous GHOUs, and Rosa or Carl will probably jump in and tell me otherwise, but we've heard today from Pakistan and Russia that I don't think I've been able to hear talks with before, so it's really refreshing.
We had a GHOU meeting in St. Petersburg.
I wasn't invited, Carl. I probably wasn't invited for international reasons. It's probably best, but okay, we had one in St. Petersburg. I apologize. Okay, so as GHOU we have been there before. Victoria, at this point, then we're probably going to move on to our next speaker, if that's okay.
Awesome.
Thank you very much for your time, and hopefully there are people that will get in touch with you as a result of your talk today.